Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your yeast lactic fermentation. Okay, so we are already discussed about the lactic fermentation in our previous lecture and the video related to this is already uploaded in our account. You can go and check. Here the topic that we are going to discuss is yeast lactic fermentation. Okay, so let's start the lecture. Although yeast lactic fermentation of various substrate have been recorded in many countries. Okay, before starting the lecture, we have to know that what does the yeast lactic fermentation means? What does this word means? Basically, in yeast lactic fermentation, both type of the microorganisms are involved for a fermentation. That is your yeast and along with it lactic acid bacteria, lactic acid bacteria, both are involved for the process of the fermentation. Okay, it is mainly in Eastern Europe that milk provide the raw materials. These alcoholic milk beverages have a lactic or a sour taste. Okay, so basically the alcoholic milk beverage have what they have a either lactic taste or a sour taste is totally depend upon the which species are present in the starter culture. Okay, starter culture means that the culture that is used for this starting the fermentation. Okay, so the taste of the alcoholic beverages is totally depend upon the type of the species present in a starter culture. According to them, the alcoholic beverages give a lactic or a sour taste. The ethanol content could be as high as 2 gram 100 ml. Okay, and the traditional product also have a foaming and effervescent characteristic which give a result of CO2 production. The microflora of the starter culture for these products is not well defined, and the typical example of such beverages are kefir and related product, that is your pomace, acidophilus, yeast milk, and the product originated Central Asia between the Cuisine Mountain and Mongolia. Okay, so these beverages are the example of the yeast lactic acid fermentation, that is your kefir, pomace, acidophilus, yeast milk. So in today's lecture, we uh, focus on kefir. We focus on the kefir. Now come to the next topic, kefir. Okay, so in kefir the starter culture is what? Kefir grain. Okay, kefir grain is what? It is a starter culture. Basically the starter culture are defined as, anyone knows what is the starter culture? So simply starter culture is what? Here I'm going to write it. Starter culture is a preparation of living microorganism which is used to start the fermentation, which is used to start the fermentation. So in case of a kefir, the kefir grain are what? They are the starter culture and they are characterized by a irregular, folded and uneven surfaces. Irregular, folded and uneven surfaces, and this grain are what? They are white or yellowish in color and they have a elastic consistency. They are what? They are yellowish, white or yellowish in color and they have a elastic consistency, and the diameter of the kefir grain are in the range between 1 mm to 6 mm and sometime more, and the diameter are totally depend upon the extent of the agitation during its growth in the milk. The diameter is depend upon the extent of the agitation during its growth in the milk. However, when the grain are recovered from the milk and then washed with the help of the water, they give a variable size, and the size are ranges from 0.5 centimeter to 3.5 centimeter in diameter, and they have very resemble to the cauliflower florist in shape and color. The exact origin of this caffeine grain are is unknown, but um, according to the legend, this caffeine grain are um, given to the people living in a Caucasian mountain, possibly by a prophet Muhammad. Okay, now the next is microflora of this caffeine. We all know that, as mentioned elsewhere, this microflora of the caffeine grain is totally complex. The microflora of this caffeine grain is what? It is very complex and not always constant. It is complex, and along with it, it is not constant. It consists of an unrefined mixture of species of bacteria and the yeast. That's why it is known as a product, that is your yeast lactic acid fermentation product. However, according to the Tamim and Marshall in 1997 and Kiwaza et al. 1998, they reviewed that the detailed organisms that have been identified in a kefir grain by many researchers in a different countries, and the summarize of this are discussed in a next diagram, which give a different species of yeast, lactic acid bacteria, lactobacillus species, plus lactococcus species, leuconostoc species, and S. thermophilus acidic acid bacteria, which is acetohacter and acetic resin, mold, that is your geotrichum, and cadmium, and the other bacterial contaminant which is found in a grain. In some countries, uh, A acetic or A resins and G cadmium are also regarded as a contaminant which are present in other countries. They are considered as a desirable. Now the next is your commercial developed kefir starter. Okay, so this foamy and effervescent drink has always achieved a great popularity in Eastern Europe. This caffeine is what they are, a foamy and effervescent drink, and they are achieve a great popularity in Eastern Europe, but elsewhere consumption is totally limited to a minority market. Nevertheless, attempts are being made in Canada, Sweden, and Germany so that they will standardize the product and perhaps within its appeal. But it is not notable that the neither of the proposed a process is traditional. Thus, the German system employ a mixed culture. The culture is, that is 2 ml per 100 ml of inculation rate of lactococcus species as thermophilus and lactobacillus species, that is your lactobacillus acidophilus, lactobacillus brevis, lactobacillus delbrueckii subspecies lactis, and the ratio of is that lactococci and lactobacilli of 20 is to 1, and the yeast is Canada Kefir, and the Swedish process is three-stage program employ kefir grain, but it is spread over a 3 days. Now the next is your, these are the you can say that composition, just a minute, composition of the microflora in a kefir. Okay, however, Weisier in 1978 AB they proposed making kefir with the proportional of L lactis subspecies lactis biver diacetyl lactis. Okay, the next species is your lactis mesenteroids, subspecies mesenteroids, or subspecies dextratranicum. The next is your Lactobacillus paracasi subspecies, Alactosus, Lactobacillus beverellus, Lactobacillus celobiosus. Okay, they are what? They are the composition of the microflora of the kefir. Microflora of kefir grain, either they contain yeast, lactic acid bacteria and the contaminant. Okay, so this kefir grain are made up of yeast, lactic acid bacteria and the contaminant, and also a acetic acid bacteria. So in yeast, the species which are present is Saccharomyces species, Coloveromyces species, Candida species, Mycototola species, Torulopyces species, Cryptococcus species, Pistacia species, and Torulaspora species, and the lactic acid bacteria, that is your Lactobacillus species, Lactococcus species, as Thermophilus species, Leuconostoc species. Acetic acid bacteria, which included Acetobacter acetylresins, contaminant, that is your Geotrichum species, Pediococcus species, Micrococcus species, Bacillus species, Echeria species, Enterococcus species. However, the so-called buttermilk plant, which is used domestically in a northern Ireland and they have origin in imported kefir grain, has a microbial flora which consists of predominant species, that is your Lactobacillus species, and some Lactococci, S. cerevisiae, lactose, and Canada kefir, that is lactose plus. Okay, so most of the kefir which is produced by a conventional product by using a kefir grain as the basic column, and they are also composed as an indicator and earlier mixture of the microorganism which are held in a highly organized pattern. The peripheral layer of the granules, which are dominated by a various lord-shaped bacteria, but towards the center, these yeast become the major component of the microflora. What is known, however, is how these units are built up, and nor do we know the nature of the relationship between the constituent organism, and yet the granules proliferated freely in a milk with no detectable changes in a character. Production of kefir bulk starter. So, if we talk about the traditionally, then the production of the kefir involve the recovery of the grain. They are what? They are a traditionally method. And it is also involve their reuse after the washing. Okay, so in traditionally what we do, we reuse the kefir grains, that is called the recovery of the grain. However, this method of production retain that typical characteristic of the kefir in a large scale operation, and the method has a following limitation, that is your excessive washing of the grain with ultimately modification the balance between the microfloras, and the activity of the kefir grain will also decreases, and the process is somewhat laborious, and the estimated product time of the starter product is around only 2 days. Over the year, Koroleva, they develop a method for the production of the starter culture for the kefir in the former USSR, also illustrated as systematically the different manufacturing stages, either one or two could be used. They are what? They are the manufacturing stages. According to the Koroleva, both the starter have been recommended for the kefir production, but starter 2 is only used in a factory. Okay, so we can use either starter 1 or starter 2 for the production of the kefir. Okay, but if we talk about a industrial point of view, then the starter 2 is widely used in case of the factories if the equipment for separating and washing the kefir grain from the product is not available. It is evident, however, that careful handling of the starter culture is important so that it will maintain the appropriate ratio between the various microflora in a kefir grains. So this is the systematic illustration of the production of the kefir starter culture, and the final product skim milk is heated to 95 degrees Celsius for 10 to 15 minutes, and then it is cooled to 20 degrees Celsius. Okay, so first of all, this is your kefir grain. Okay, here I started. Now we wash, and this kefir grain should be washed, and the ratio of the kefir grain is around 1 is to 30 to 1 is to 50. Okay, now it is inoculate and then it is incubate for 18 hours. So after that it will cool to 8 to 10 degrees Celsius, ripen for 20 hours. Okay, now here starter 1 and starter 2 will be added. Okay, in that case then it is go to the inoculate with starter ferment for 8 to 12 hours, which are followed by a agitation and slow cooling for 10 to 12 hours. Okay, and here what we do, we even we separate the caffeine grain for a reuse. Then here standardized cow milk will be added, and not this cow milk is not fortified, and then we warm it at 70 degrees Celsius, homogenize at 15 MPa, then again heated to 90 to 95 degrees Celsius for 2 to 3 minutes, then again cool to a 20 degrees Celsius. Then it is converted into then it is transferred into a bottle. The production and ripen in the cold store. Lactic acid and 2% of the alcohol, then it is go to the store and dispatch. So this is a production of the kefir milk. Method of the manufacture of the kefir. The technology of commercial made kefir. The raw material for kefir is usually a whole milk. Okay, so usually this raw material for the production of the kefir is what? They are a whole milk, and the commercial technology of kefir are made in Ozer and Ozer 2000. So in that case what we have to do, we take a whole milk and uh, give him give it to a heat treatment, and the temperature range is around 95 degrees Celsius for a 5 minute, so that the whey protein will be denatured. Then the hydrophilic properties of these denatured protein improve the viscosity of the end product, as does that the frequently employed process of homogenization. Then a portion of this processed milk is also employed to prepare the inoculum, and then because of the nature of that starter culture, strict level of hygiene are essential. If we don't follow a proper hygienic condition, then it means that the contamination will occur, and it will, like you can say that it will like spoil or contaminated, and it will not be used, or it give a harmful effect to the health of the human being. Now the next is your, does the initial stage of the culture preparation involve inoculating the pre-treated milk with the kefir grain, and then again incubate the mixture around 23 degrees Celsius. After 20 hours, then the grain are sieved out of the milk, and then it is carefully washed with the help of the cold water prior to reuse. Then the remaining milk provide the bulk starter for the commercial scale fermentation, and in this process the addition of the milk at the rate of is around 3.5 ml per 100 ml. Okay, if we have a 100 ml of milk, then we add a starter around 3.5 ml, and the final incubation take place at 23 degrees Celsius for 20 hours. Then after 20 hours the product will be cool, and the kefir is often held for a several hours to the ripen. This This later stage allow for maximum stability of the coagulum, and the final packaging stage must be designed in such a way that a mechanical damage to the product is kept to a minimum. Thus, while kefir is investigate as a refreshing drink, it is quite distinct viscosity that is regarded by a devote as an essential feature for a good quality of the product. Now, the next is the chemical changes that take place during the fermentation and the storage of the kefir, shown in a table 8.9. Nevertheless, it is safe to conclude that the quality of the product is greatly influenced by these three things. That is, the first one is your origin and microflora of the caffeine grain, which are present in the starter culture, and the second is the type and the quality of the raw material. According to the Wislock et al., they evaluated that the quality of the kefir, which is produced from cow, goat, and sheep milk, they have which is used in kefir grain, had 2 dvi kefir starter culture, and they reported the following observation. The first one is your lactic acid bacteria and yeast were abundant in fresh kefir, but strain are decreased by 1 log cycle after 12 days storage. The next is your microbial metabolites, that is your free fatty acid, diacetyl ethanol. They were associated with the species of the milk which is used, and then former two component which is affected by the storage period. Then the last is your next is your ferments of the kefir milk influenced by the type of the milk, protein content, which is average 6.4, 3.9, 2.9 per 100 gram respectively. And the last is your all the sensory properties, that is your flavor, odor, texture, mouth feel, and the acceptability. They were influenced by the species of the milk during the storage effect, which is influence the mouth feel characteristic. So this is your diagram which represent the production of the kefir from a rhodia texel free dry culture. No kefir grain are produced. Here DYI milk sachet 15, then incubation at 21 to 23 degrees Celsius for 18 to 12 hours. Here the kefir, then inoculate milk sachet 3 1, incubation at 21 to 23 degrees Celsius, intermediate culture, bulk culture, then inoculation milk and incubation at 21 to 23 degrees Celsius for 8 to 20 hours. Then inoculate milk 3% and incubate at 21 to 23 degrees Celsius for 18 hours. Then we get a kefir. The first one is your D culture, then this is your M culture, then SD culture, in which inoculate the milk sachet at 15 L 150 per liter, then incubate at 21 to 23 degrees Celsius for 18 to 22 hours. Here the bulk culture will be added, and then again milk are inoculate 23% and incubate at 21 to 23 degrees Celsius for 18 to 12 hours, and we get a kefir. Now the next is your traditional preparation for a bulk starter. This diagram represent here preheating 65 to 70 degrees Celsius, homogenization, heat treatment, cooling, incubation, intermediate, ripening, cooling, packaging, and cold storage. Here, gross chemical composition of cow milk and kefir during the storage at 5 degree Celsius. Here, the first column is component, then the milk, then the kefir ratio. The component that we get is moisture, fat, lactose, ash, alcohol, lactic acid, carbon dioxide, casein, globulin, albulin, peptide. Okay, so this is all about the yeast lactic fermentation, and in which we focus about the kefir. I hope you will understand, but if you have any topic, if you have any query related to this topic, you can ask me in a comment box, or for a further detail you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, and LinkedIn. And subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Or you can also ask your query to the helpline number that are already mentioned in your slide, that is 7080833450, and visit our website www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.